We often think of air as a set of isolated numbers, temperature, humidity, VOCs. But air doesn't change on its own. It changes because we move through it. This is the PROXIMA-NODE, an evolution of the Velo node built for those who want a deeper connection to their environment, not just through chemistry, but through interaction. By pairing high-precision gas and thermal sensors with a simple ultrasonic gesture field, PROXIMA becomes more than an atmospheric monitor. It becomes a spatial observer, an instrument that responds to the moment you reach for it. And despite its finished professional appearance, the internal engineering is a complete departure from traditional electronics. There are no green circuit boards inside this frame, only printed geometry, mechanical logic, and a wiring system you can assemble yourself. All you need is a basic 3D printer, or access to one, to build this at home from a few simple parts. This isn't something you buy, it's something you build. To protect the integrity of its readings, PROXIMA-NODE uses a controlled dynamics architecture, a layout where airflow, heat, and interaction each have their own defined space. The sensing chamber sits inside a thermally isolated pocket, shielded from the warmth of the microcontroller, the display, and the interaction hardware by a printed internal wall. Fresh ambient air enters through the openings around this chamber, giving the instrument a clean, passive intake while preventing heat bleed from the electronics. Just beside it, carved into the body, is a pair of narrow openings that form the interaction bay, a small spatial corridor that responds only when you choose to reach toward the device. It doesn't watch the room, it doesn't track motion, it simply waits for your presence at close range. Every wall, opening, and partition exists with intention to keep the chemistry pure, the interaction deliberate, and the instrument stable in any environment. At its core, PROXIMA-NODE runs a dual-domain sensing engine. The ENS-160 acts as the digital nose, reading VOC activity and generating stable IAQ and ECO2 estimates. The AHT-21 provides the thermal and humidity compensation that anchors those readings. And then there is the HCSR04, not for room sensing, not for motion detection, but for interaction. A short ultrasonic pulse creates a narrow gesture field directly in front of the instrument. Move your hand through that field, and the interface advances, switching to the next page of data, temperature and humidity on one page, gas chemistry on another, a combined overview on the main screen. It's a simple, contactless way to navigate the instrument without touching it. And because the interface is modular, you can add your own pages, a graph, a trend view, or any custom layout you prefer. The ultrasonic sensor doesn't watch the room. It simply knows when you choose to interact with it, nothing more, nothing less. Inside PROXIMA-NODE, the electronics follow the same principle that defines the Vanguard Tier. The structure is the circuit. The 3D-printed PCB doesn't route signals as etched copper traces. It routes them as physical geometry, carved channels, mechanical anchors, and pressure-fit terminals that hold each connection in place. It's a board without a board, a design where printed plastic replaces fiberglass and geometry replaces traditional copper routing. Every module seats into a mechanical socket. Every wire follows a guided path. The logic of the instrument is mapped directly into its body, a clean physical architecture that trades industrial waste for intentional design. Print the body, route the wiring paths, seat the sensors, secure the microcontroller, close the enclosure, a solderless instrument built from first principles, where the form and the function are the same physical object. If you want to explore the wiring technique that makes this printed PCB architecture possible, there's a dedicated tutorial that breaks down the process step by step. It's linked in the description. Traditional electronics rely on flat fiberglass boards, brittle planes etched with copper and assembled through chemical baths and automated factories. Flex them, drop them, or stress them, and a single cracked trace or fractured solder joint can kill the entire device. PROXIMA-NODE has no such weak point. Its internal wiring channels are engineered to sub-millimeter tolerances, using the natural friction of the printed plastic to clamp each solid core wire in place. When a sensor pin seats into the terminal block, it forms a high-pressure, mechanically sound cold weld against the wire. No solder, no adhesives, no failure points. Shake the chassis, turn it upside down, tap it on the desk. Nothing moves, nothing flickers, no rattle, no loose connections. Just a rigid, unified structure where the body and the circuitry are the same physical object. PROXIMA-NODE doesn't watch the room. It watches you. The ultrasonic field is intentionally narrow, designed only for hand-level interaction. Move your hand through that field and the interface advances to the next page. No buttons, no contact, just a small gesture in the air. And the instrument responds. It feels quietly futuristic, like the device is listening to your intent rather than your touch. Navigate between the main overview, the detailed chemistry page, the temperature and humidity page, or any custom pages you choose to add, including graphs or trend views. It's not motion detection, it's intentional interaction. PROXIMA-NODE communicates through MQTT, a protocol built for instruments that need to speak quietly, quickly, and without overhead. It sends out only what matters: the chemistry and comfort of your air. Each reading becomes a small signal published to a topic you control. Think of it as a private channel, a place where Proxima leaves its notes, and any device that knows the topic name can listen. It streams the essentials: VOC levels, humidity, temperature, IAQ, and ECO2 estimates. The gesture interface stays on the device. Only the environmental data travels. I've built a dedicated MQTT viewer on my website, a clean real-time window where any topic can unfold as a living graph. Enter your node's topic and the chemistry of your room becomes visible as it happens. No accounts, no hidden pipelines. Your data moves only where you choose to send it. PROXIMA-NODE isn't just compatible with your infrastructure, it becomes part of it. We spend our lives surrounded by devices that watch us, track us, and report to places we'll never see. PROXIMA-NODE is built in opposition to that world. It doesn't harvest your presence. It doesn't profile your behavior. It simply responds when you choose to interact with it and stays silent when you don't. This is an instrument you can open, repair, and understand from the inside out. A tool that treats your home as a private space, not a data source. Its chemistry is transparent. Its interface is intentional. Its logic is yours to inspect. Proxima continues the philosophy that shaped the Vanguard Tier. Instruments that belong to their owners, not to a cloud. Tools that give you sovereignty over the physics of your space, from the air you breathe to the way you choose to read it. If you're curious how this whole approach to open, printable instruments began, I've made a separate video that walks through the origin of the system. The link is in the description. This is PROXIMA-NODE, the intersection of chemistry, interaction, and physical logic. If you have a 3D printer or access to one, the files, wiring maps, and firmware are available on my site. Build the instrument, explore your air, interact without touching. This node is part of the Vanguard Tier, a growing family of applied instruments. If you want to explore the other nodes in this tier, the links are in the description. If you want to follow the evolution of this system, consider subscribing. And if you know a fellow maker who would appreciate this design, feel free to pass it along. Thanks for watching. I hope this inspires you to build the tools that give you sovereignty over your world from the sensors up.